Okay, welcome to Unit 4 in our course, Trigonometry, which happens to be Unit 8 in your textbook. Those of you with duotangs would just continue on after the congruence and similarity section of the textbook. So hopefully you worked through that work. If you were not there on the Friday before March break, all the filled in notes are on D2L already. This is going to be a new module under Unit 4, Trigonometry. So there will be a blank PDF of this video slideshow that we're going to go through. So if you like to fill in your notes as I go along, just like we do in class, then you might want to pause the video and go print off that note. Or if you have an iPad and you can write on it or whatever you're going to do for your notes for this section. So moving forward, since we are not sure how long we are going to be closed, then just make sure you're checking D2L so that you can watch the video lessons and complete the appropriate homework. So we're continuing with our study of triangles. Last year in grade 9, you would have done side lengths of right angle triangles using the Pythagorean theorem. Now we're going to extend that to finding the measure of an angle using the primary trigonometric ratios, which is basically this lesson here, 8.1. Then we're going to solve problems using right angle triangles. And then we are going to move away from just right angles, and we're going to look at the sine law and cosine law for finding side lengths and angle measures in triangles that do not have a right angle. And as well solving problems with those. Okay, so what is trig? It is the area of math that studies the relationship between the angles and side lengths in a triangle. So the first half of the unit will be investigating right angle triangles using relationships described by the three primary trig ratios, sine, cos, and tan. So we'll talk about what that acronym means, SOH CAH TOA here. And then, like I said, the second half will be investigating triangles that do not contain a right angle using sine and cosine law. So it's just some homekeeping. You are going to need a scientific calculator that has buttons that say sine, cos, and tan. So you can use a phone, as you know. Obviously, if we eventually get to formal assessments, not like in class, like if we go back to school, you will not be able to use your phone. So I don't recommend that you use your phone. It's also not super user friendly to turn the phone sideways, and the notation on there is a little bit funky. So if you have a calculator, I recommend that you get the calculator and you get to know how to use it. So one of the examples we're going to do today as we work through these new primary trigonometric ratios is practicing with the calculator and using those buttons. Those of you that took academic science and did Snell's law, so you would have looked at some trig ratios. So sine theta is part of Snell's law, so that is the same sort of idea here. So whenever you have a triangle, then the ratios it's essentially like eventually if you take 11U or 12U math, then advanced functions, then they will talk about special triangles, and this is basically ratios using the principles we talked about in the similar triangle section. Okay, so if you have an actual calculator, it has to be in degree mode. Radians or rad or grad will give you the wrong answer. So those are different kinds of units to express these relationships that eventually you'll use when you move on, not in grade 10, we're just going to scratch the surface, but if you move on to the upper years with looking at the graphs produced by sine and cosine functions, but that's not what we're going to do here. So you want to make sure that your calculator says DEG or D in the display. That means it's in degree mode. If you can't figure out how to get it out of rad or grad, then that the degree mode is the it's like the default. So if you know how to reset your calculator, you can reset your calculator and it should go into degree mode. Okay. So a right angle triangle is what we're going to focus on first. It has to be labeled, so it has to have that little square at the bottom to show that it is a right angle. You can't just assume. And then we are going to label the sides of the triangle. So last year you should have talked about the hypotenuse, which is the side across from our opposite to the 90 degrees, which is the longest side. We're going to continue using that name. But then the other two sides, we're going to call them something a little bit different. So we're going to talk about the opposite side and the adjacent side. Now, the issue here is that you can have A as one of the angle of interest that you're going to use, or you could have B up here. So the opposite side and the adjacent side are going to be different. So you need to make sure that you are paying attention to what the question's asking you for, and making sure you're looking at the correct angle. So if we look at angle B and angle C, then we can see that they are different. So when you have angle B up here, then the hypotenuse is across from the right angle, as always. And then the side...
Mommy, how are you doing stuff?
The side...
I don't want stuff the wires anymore. Yeah,
the side across from angle B is called the opposite side there. And it's the side length AC. But then when you have the adjacent side, it's going to be this side here next to the angle, which is BC. Then if you're looking at angle A down here, the hypotenuse is still the same side, the longest side, but the opposite side is now different, and as well as the side next to it. So again, read the question carefully. And the first step when we do the examples, the first step labeled is to label your triangle so you know what you're talking about. Okay, so the relationships between the sides and the angles, we are going to describe them using the three trigonometric ratios: sine, cosine, and tangent. And in grade 9, you would have used the Pythagorean theorem to calculate side lengths. So this is the next step in questions that can involve angles. So we're going to use the Greek symbol, the Greek letter theta. So again, if you took science, you would have talked about Snell's law there. And so we're going to use that to represent any angle in the right angle triangle. So when you do an example, like way down here, later on in the note, then you can see that theta is labeled as such, and it wants you to find that angle. Okay, so just a little bit of a different notation there. Okay, so now the three ratios are sine theta, which is when you are looking for or given the opposite side and the hypotenuse. Cosine theta is when you are looking for or given the adjacent side length and the hypotenuse. And tangent theta is the opposite side length and adjacent side length, no hypotenuse at all. So we usually use short forms, to be honest. So usually instead of writing SINE, we write sine, and then we write op and hype. And then cosine, we write cos and adjacent and hype. And then tangent, we write tan and op and adjacent. And then even further, we use a different acronym or short form, SOH CAH TOA. So in this note here, you can see the first letters are bolded. So S for sine, O for opposite, H for hypotenuse, C for cos, adjacent A, hype A, H. Tan theta, T for tan, opposite, and then adjacent. Okay, so let's practice with your calculator first. So when you type these in, again, there is a variety in how the calculator will work. So let's say we'll do A here, sine 50. So when I type in my calculator sine 50, I push the button sine, and it just in the display pops up SIN, and then I type in 50, push equals, and it gives me the answer 0.7660444443. Okay, so these will be irrational numbers. Like, you know, if you had a long calculator, it would keep going. Usually we're going to round to 4 decimal places. When you do an angle, it's usually the question will say 1 decimal place. Okay, so just take a look for that. So the final answer rounded to 4 decimal places is 0.7660. Some calculators, when you push the sign button, you're going to get brackets, which is no big deal. You can close them or not in this case. Some calculators, you push the number first and then the sign button. I would call these calculators unfriendly, but they will work. So you just have to make sure. Usually these kinds of calculators don't have a display, which can give you all sorts of problems and all sorts of types of questions. But if that's all you've got, then that's what we'll go with. Okay, so take a look at your calculator, try them out. So when you push sign 36, you should get this long number here, depending on how many spots are in your display. And when you round it to 4 decimal places, you get 877. And then this number here, you look next to it, that's a number above 5, so I'm going to round up. Sign 40, when you punch it in, oops, gives you this number here. And again, you do 4 decimal places, 6, 4, 2. Take a look at the 7. Look next to it is going to be an 8. Okay, so the first type of example we're going to do is to solve for side lengths given an angle. And actually, if you could humor me and switch to this example first. So for some reason, it got printed out of order. I apologize. We're going to do B, and then we'll go back and do C. Okay, this one's a little bit easier. So determine the value of X to 1 decimal place. If you are a highlighter, give the angle a little highlight so that you can see which angle we're given. So it's step number 1 on the side here says label your triangle relative to the angle. So then what that means is over here, so that is across from the 51 or the opposite side, whereas the 30 here is the adjacent side. I don't want to write it on here because we are not given the side opposite to the right angle or the longest side, the hypotenuse. So I'm not even going to label it on there. You certainly can, but just be wary because we're not going to use that. So when you go to solve for this, we're going to figure out using SOH CAH TOA, which one do I use? So we're asked about the opposite side, we're given the adjacent side, and that means that we're going to use the tan ratio. So tan theta, you can certainly write out the whole word tangent, opposite, adjacent, but most people do not do that. So TOA, so tan, T, opposite goes on top because it's written first, and then the adjacent goes on the bottom. Okay, we have already labeled it. The theta is the angle. If you want to write that for yourself, you can. So tan of 51 is opposite over adjacent. So now you have choice. It does say X here for opposite. You can put the X, you can leave it as opposite. It doesn't really matter. Okay. All right, so now we have a little equation. We have one unknown and we need to solve for it. So if we want to get X by itself, then what we're going to do is you have to multiply, right? We're going to do the inverse operation so that these 30s cancel. If you multiply on one side, you have to do the same thing on the other side. So the same principles of solving equations that you would have learned in grade 9 and that we've already reviewed tons and tons of times, right? So now in order to get X, we're going to do 30 times tan 51. So tan 51 is just a number, okay? So if that freaks you out, you can certainly type in that number instead of writing out tan every time. It doesn't really matter, okay? So it does say in the question to round to 1 decimal place. So we are going to do that. So when I type in my calculator, 30 times tan 51, I get 37.0469, blah, blah, blah. But that is not what we want to leave our answer in. So I'm going to write 37, one decimal place. You take a look at this one, and then next to it is a 4. So that means we are going to keep it the same, round down, and that's our answer. Okay, so 37.0 centimeters. So similar to other questions, if it says centimeters here in the side links, make sure that you put centimeters in your answer. Okay, so let's go back to C and attempt this tricky one. Okay, so now you can go over and highlight the angle we're talking about, and then label your triangle. So now across from the right angle or the longest side is the height, and then we're looking for across from the 42 we are given 4.5 meters. So that is the opposite side to the 42 degrees Celsius. Okay, so we have the theta is 42, not degrees Celsius, sorry, degrees. 42, and then let's look at what else we're given. So we're given opposite, we're asked to find the hypotenuse, which means we're going to do sine. Opposite over hypotenuse. Okay, so I'm going to plug in what I know. Okay, so now we have a bit of a problem. The x is in the bottom, which can make your life a little bit tricky, but you just have to think about what we're trying to do. It's sort of the same principle, it is the same principle as the other one. There's just always going to be an extra step when it's in the bottom. So I'm going to show you 2 ways to do this, okay? So if x is in the bottom or divided, then in order to get it out of the bottom or the inverse operation, we're going to multiply just like we did with the 30. Okay, now then to get rid of, to isolate the x, then what we need to do is divide by sine 42. So some people that freaks them out, the sine 42, they would like to have it as a number. So you can certainly do that. So I'm going to write that over here. So sine 42 is 0.6691. And then maybe that to you looks more like a solvable equation. Okay, so if I want to isolate x, I need to divide by 0.6691. Or you can keep the sine 42 because, maybe you like that better, but it's the same thing. You're going to get the same answer. Okay, so another possibility for this, like if you go back to this step here, is you can flip the fraction. So every number is over 1. So if you want to flip this side, then you can certainly flip this side as well and solve for x that way. So then you're going to multiply by 4.5. And you're going to get the same answer. So then it would be 4.5 times 1 divided by sine 42. But again, it's still 2 steps. It's a little bit less straightforward than when the unknown variable is on the top. But it's the same thing. So some of these have multiple steps and some of them don't. What I recommend that you do is on the last page is a list of homework questions. Do as many of those questions as you possibly can so that you can see or you get a wide variety of the different types of questions you could be asked. Okay. So now what happens when we need to find an angle? So when you're trying to solve for theta, remember we're going to use that as our symbol. That's like our x. Okay, so that's our unknown. So if you have something like this, tan theta equals 0.3711, then if you want to get rid of the tan so that you can isolate the theta, then we're going to, similar to whether you're multiplying and dividing, you have to do the inverse operation. So and the inverse to that is written as -1. So most calculators have these buttons together. And then above them, it says this. So usually it's like shift or second function, whatever your calculator does. So these go together. So the inverse operation of sine is sine to the -1, cos -1, tan -1. So back to here, tan theta equals 0.3711. Then to get rid of the tan, you do tan inverse. Okay, and then you usually would do 1 decimal place for angles. So sine theta equals 0.3907. Then you have to do inverse sine is 0.390. Inverse sine 0.3907 gives you 23 degrees. Cos theta. So then you can leave it like this. And then those of you that your calculator puts brackets in already, then you would want to.
I can't read this one.
Then you would want to divide by that, or then that'll do the dividing for you, and then you'll get an answer.
Peppa's family are having a sleepover at Cousin Chloe's house.
You'll get an answer of 58.5 degrees. Okay, so what are we doing? What's happening here? Again, we're doing the inverse operation. So if you had 2x equals 6, then how do you solve for x? You would divide by 2 on both sides. So then you would do divide by 2, right? And you would get x equals 3. That's what we're doing. So sine theta equals 0.667. We're doing sine inverse here, which cancels out. And then that means you have to do it on this side. But most calculators, you push this first, so write it like that, and then you get to 1 decimal place, 41.8 degrees. Okay, so now let's do some more. So again, whatever it says, so this one says cos theta, so then you're just going to do cos -1, 0.667 gives you 48.2. Tan theta and then you get 33.7 degrees. Okay, so now we are ready to solve for angles in a triangle if we are given side lengths. Okay, so here again, if you want to highlight what you're looking for, your angle, it's up here. We're going to label the triangle. So we've got the opposite side, and then the side opposite to the right angle is the hypotenuse. You can write out SOH CAH TOA again. And we have the opposite side. We have the hypotenuse, which means we're going to do sine. So this time our unknown is the theta, the angle, and it tells us 1 decimal place. And we're going to do opposite over hype. Five over 13. So again, you can decide for yourself. Are you going to divide this first? 5 divided by 13 is 0.3846, or you can just leave it. And then, so what you're going to do is the inverse. So to get theta by itself, the inverse of sine is sine inverse. Just need some more space there. 5 over 13. Okay, so you can certainly do that. And again, those of you that have a calculator that puts brackets in, that is an easy thing to do. You just have to close the brackets. It already does it for you. So a little bit less steps there if you're into that. Okay. All right, so let's do another one. Oops. Okay, so now we're going to label our triangle. We have the height across on the right angle, and then this time now we have the side next to or adjacent to the theta. Okay, we've got hypotenuse, we've got adjacent, so that is cos. Okay, so the inverse of cos is cos to the -1, which is 62.964. So then when you round that, you're going to get 63. Okay, no problem. So the important part here is, like, the inverse part is no big deal, right? Cos, the inverse operation of cos is cos -1. You just have to make sure you pick the correct ratio in the first place. So let's do this last one with the last kind of ratio that we haven't done yet. Now, I don't know why these are circled. That doesn't really matter. Okay, so we have the opposite side and the side next to it, the adjacent side. Nothing, no information about the hypotenuse.
Mommy,
Shh.
can I do something else?
Yes. Okay, we have opposite, we have adjacent, so that's going to be tan.
Can I do this? Can I do this?
Yes. Okay, so we're going to do tan. So then the inverse of tan is tan inverse, tan to the -1. This one I'll do the dividing first. For those of you that maybe don't have brackets on your calculator.
What are you guys doing? Mommy's making up a video.
So you get 56.5 degrees. Okay, and then the last kind of question, sketch the triangle ABC in which angle B is 90 and cos A is 5/9. So I don't have a ruler on this, so do a better job than me. Okay, so it tells you to put in angle B as 90, and then that's really the only indications you're given. So you can choose to do that. Oops. Or this. It's just going to, it doesn't really matter, but you just have to make sure when you think about what cos A is, which is 5/9. So again, when you do SOH CAH TOA, cos is adjacent over hypotenuse. So this is the adjacent side and this is the hypotenuse. So that's easy. In either triangle, you can put that right in. And then when you do the adjacent side, you just want to make sure you're doing it in relation to angle A. So the adjacent side here is going to be to angle A is 5. If you put the A down here, then the adjacent side would be 5. Okay? There are quite a few questions here listed, but you should definitely try as many of these questions as possible. If the question says to solve the triangle, that means you need to solve for all of the unknown sides and all of the unknown angles. It wants everything. Okay, so good luck. And if you have any questions, you can email me. Okay,